All right, so I've decided to give you a video walkthrough of everything that's going to be on the test by way of review. So here we go. Where's my annotation? It's right there. Let's get a good color, something like that. Number one says, what is the average rate of change given by this function? The function is f of x equals x cubed minus 2x plus 3. The average rate of change is simply the slope of the line between 2 points. And we are given our x's right there. So we'll make just the tiniest little table here, x and y, and we'll call this point 1 and point 2. So at point 1, our x is going to be 0. And if we put 0, we got 0 cubed is 0 times minus 2 times 0 is 0 plus 3. So that's 3. And then for 5, we got to put in 5 cubed. That's going to be 125 minus 10 plus 3. So for our second point, which is the x equals 5, the y is going to equal 118. So now all we have to do is say, well, we know our basic formula for the slope of a line, y2 minus y1 over x2 minus x1. That's the same thing as saying rise over run, right? So we're going to get 118 minus 3 over 5 minus 0, right? So that's going to give us 115 over 5. Well, that's different than when we did it before. Let me just double check that. 5, 125, 10, 3. Yep. And y1 is 3, y2 I did correctly, 118, 0 and 5. So 115 divided by 5 is going to be 23. So that's the answer to that one. The average rate of change was 23. That's the slope. Quite a slope, isn't it? But you know, it's a cubed function, so it's going to have a pretty, by the time it gets into 3 or even 3 or 4, let alone 5, it's going to have a very amazing and large and serious slope. So now I will erase everything. And we'll go to the second one. At x equals 4, the function given by f of x is that. So it's asking if it's undefined, if it's continuous, and if it's differentiable. So the first thing we got to look for is it defined? And you got to look for two things. One, is one of those greater than or less than or equal to? Because if neither of those have the equal to added to it, it's not going to be defined, right? So the lower one has the equal to, but then you just got to check and make sure the function is actually defined at 4, right? And 8 times 4 is 32 minus 16 equals 16. So this function certainly is defined at x equals 4. So we can already rule out undefined, and if something is differentiable, it is by definition continuous. It can't be differentiable but not continuous, because differentiability is about having a slope, a definable slope at a given point, and continuous is about whether it's connected. So it can't have a slope but not be connected. So there's no way it can be differentiable but not continuous. So now basically we got to ask, is it continuous and is it differentiable? So continuous is basically about whether or not these 2 points, whether or not those two functions touch at, do they touch at x equals 4, right? So then we just do that. We say, well, x squared, at x equals 4, x squared, that's the first one, right? So at 4, we're talking about 4 squared equals 16. And the other one is 8 times 4 is 32, excuse me, minus 16. That one also equals 16. So it is definitely continuous. So we can check that box off. Now, the only question is it differentiable? And that is the last thing we're going to check. And differentiability means that it has to have the same slope from both sides. Because if something is if something's a sharp point, it could go like this, right? Something like that. If something's a sharp point, you can get a slope. You can get a. You could legitimately talk about a slope right here. You could talk about a slope of a tangent right there. You could talk about a slope of a tangent right there. But right here at that point, it's just a single point, and you can think of it like a teeter-totter. It's just going to rock, right? So there's no way there can be a point. So what you have to check is if the slope of both functions is the same right where they meet. All right? So that's the thing we're going to do. And here's how you do it. So what is the slope? So if f of x equals x squared, how do I find the slope of the tangent line of that function at any given point? Well, that's what the derivative gives you, right? It gives you the slope of the tangent line at any given point. So we have to just find the derivative of this. And f prime of x squared just equals 2x, right? So then we know if we say, okay, f prime of, and we're talking about 4 here, equals 2 times 4, that equals 8, right? So the slope of the upper function is 8, right there as it hits x equals 4. Now, what about the other one? Well, that is actually, this one here is already in this form, isn't it? Y equals mx plus b. And so the slope m is already here, and it's right there, isn't it? It's 8. So the slope of the first function is 8, and the slope of the second function is 8. So, we could have crossed that one out a while ago because we determined its continuity. So the answer to this is that this function at x equals 4 is both continuous and differentiable. Now, that doesn't mean it doesn't change, right? Because 8x minus 16 is a line, and x squared is a geometric function. So it's going to go, there's going to be a line, and then right at x equals 4, it's going to go, woo. Sorry, that should be smooth right there. So it's going to be a straight line right till x equals 4, and then it's going to take off like that, right? So that's the way that one goes, all right? And you can review that again if you need to. Number 3, the graph of the function below is shown for x from a to b. The derivative of f exists for everything, so it's continuous, because if it's differentiable, then it's continuous. Let me say that again. If it's differentiable, it is continuous. And that can be important in teasing apart some problems. They might tell you it's differentiable, and then they're asking a question about continuity. And one of the things you have to remember is that differentiability necessarily implies continuity. So the derivative of f exists, so it's continuous for all points between a and b, except it's not differentiable at 0 because, as we can see, there's a sharp point, probably an absolute value function or something. For how many values of c, so c is any value x equals c, which could be anywhere between a and b, right? For how many values between a and b does, and let's take this apart. I'm going to do the second one first. This piece right here, what is that? That is actually simply it's the slope between point B and point A, right? We're actually right back to this one again, y2 minus y1 over x2 minus x1, except here the y is the f of x, right? So you have b minus a, so that's your x2 minus x1, and you have f of b minus f of a right up here, so that's your y, right? That's your y, those are your y's, and those are your x's. So the first thing we're looking at is that's the slope of that line. So that's the slope of the line that goes right through here, right? It goes to those points. That's what we just did. Now, the second thing, I'm going to change colors just to, Sol changes colors. So I'm going to change colors. All right, so now the other thing. What is this? What is that right there? Well, that is simply the limit definition of the derivative, right? It's one of them. So the limit as x approaches c, so you're closing in that gap between a point and the x next to the point. So you're getting to the slope at any individual point. That's what's going on right there. So it's asking, and so that's the derivative, derivative limit notation. So that's asking about the derivative gives you the slope of the tangent line at any given point, right? Slope of the tangent line at any point on a function. Slope of a tangent line at any point on a function. Right? That's the derivative gives you that. We'll give you that. Equals is the wrong thing to put there, but you get what I'm saying. The derivative gives you the slope of the tangent line. So if that's the limit definition of the derivative, it's asking how many places does how many values of c, in other words, how many x values, how many points on this curve at x values will give you a line whose slope at that tangent to the curve is equal to the slope of this other line that we already drew, that is just the slope of the line from point A to point B. So these two things are parallel, right? Basically it's asking, another way to say it is how many tangent lines on that curve are parallel to the line that runs through point A and B. And one of the things you got to look out for is you make sure you look above and below the curve, because sometimes people miss those. So we're looking for a line parallel to that, and there's going to be one right there. That's parallel, right? It's tangent to the curve. It doesn't matter. It doesn't matter. It's there. We know it's there. It doesn't matter exactly what C it is because the question is not asking it. But we see that it's a smooth curve, so we know that it must be there somewhere, even if we don't know exactly where it is. So there's one there. There's going to be one there. Again, it's tangent to the curve at that point, right? And then there's going to be one there. And then there's going to be one there, roughly, right? So those are all going to be parallel to the line, the slope of the line, they're going to be parallel to the line that runs through those 2 points, A and B, where x equals A and x equals B. So the slope of them is going to be exactly the same, right? So just to go back again, this is the limit definition of the derivative. So there's going to be 4 values of c where the limit definition of the derivative, this thing right here, equals the slope of the average rate of change. So the slope of all 5 of these lines is going to be the same. The slope of all of these lines, I should have used a different color. The slope of all those lines is going to be the same, and that's what they're asking there. Hope that brought more clarity instead of confusion. All right, so now let's, I'm going to scroll up a little bit. And okay, so the next one is a little bit of it's more of a thought problem than anything else. So the next one says if f of x equals x, now that is a function, right? Then what does f prime of x, f prime of 7 equals what, right? That's what that's asking. So remember, f of x is a different way of notating, and notating a line of something like this, right? That's the same thing as f of x, except that when we use function notation, that allows us to conveniently put in a number for x instead of saying our line is defined by y equals x, and we want to know what's going on at x equals 2, right? We could say this, but that's very cumbersome compared to just saying f of 2 equals x, because now we're asking what's the value of this function x at x equals 2, right? So I'm going to do a little bit of erasing here. Get rid of that. And now we're going to go back to our original question, and we're going to take it apart. And you're going to say, oh, that's wonderful, and you're going to love it, and you're going to go, ooh, I think I'm really getting it now. Okay, so back to our pen here. So if f of x equals x, f of 7 equals what? F prime of 7. So let's just do it mathematically. So f prime of x equals what? What's the derivative of x? Well, this is going to be, there's a 1 there, right? That is implied. So we'll pull that down and put that in front of the x, and then we make that x, this is just power rule, and you guys all know this already, and then we subtract 1 from the current exponent in the function, and we get 0, right? So we end up saying that f prime of x equals 1, which makes sense because, we'll just go over here, because the line defined by y equals x is what? What does that line look like? It's just, all it is this, right? That's y equals x right there. So that's the same thing as saying f of x equals x, right? Either way, same thing. So now we'll go back over here, and this says f prime of x equals 1. Well, what does that mean? That just means the slope is always constant, right? So I could ask you, what is f prime of 2074? And you would have to say, well, that also equals 1, because the derivative of the function f of x equals x is 1. And so if we look back at f of x equals x, you could see that it's a line with a slope equal to 1. So it doesn't matter where I choose a point on this line, the slope of that line is always going to be equal to 1, which means the derivative of the function of that line is going to give you a 1 no matter what number you put in for the x, which is what we see right there. So the answer to this is 1. All right? Good. Okay, Now the next one, oh, this is a beautiful problem right here. So this is number 5. And we're doing the limit definition of a derivative on this one, where it's asking you what this thing equals. And it's the limit as h goes to 0 of x plus h squared plus 6x plus h minus x squared minus 6x. All of that over h. And I know that that looks a little crazy. Believe me, I do. But let's go back to basic limit definition of the derivative, right? So we're going to say it's limit as x goes to 0 of f of x plus h minus f of x over h. That's the whole thing right there, right? So what you're looking for when you're trying to tease this thing apart is this minus right there. Because everything to the right of that minus is what? It's the original function, right? It's the original function of whatever we're doing here. So we're going to look for that minus, and there it is. So, is this the original function? Well, not quite. Not quite. Because this minus is a powerful minus right there. It's a minus to this whole function, right? So if we were going to write this with parentheses where they belong, we would have to say minus x squared plus 6x, right? But they took the parentheses out, so that minus had to be distributed there. It's a little tricky. It's a little tricky on their part. I don't know why they couldn't just ask you straightforward questions, but then again, you are in an AP class, so you'll just have to deal with that. So what we find out here is that by looking carefully at this thing, we can discern that the original function that this is talking about is x squared plus 6. But don't get tripped up there, because remember, this thing here is not, this whole thing, that is the limit definition of the derivative, not of the function. So we tease the function out of there. Is that my class? Oh gosh, my lunch is over. We tease the function out of there. So now that's a limit definition of the derivative. So now we still have to find the derivative. And I'm going to have to end this and then do the other 3 later, which is fine. So f prime of x, power rule derivative there. Oops, I left the x off there. Power rule derivative there. And then that's just a constant. It's a power rule again, but the x to the 1 goes to the x to 0, which is 1. So then that's actually the answer, which is C. And you can see that there's a little trickiness there because they left the original function in there as well, in case you didn't realize you needed to pull the derivative of that function. So that's all for now, and we'll get to the other 3 later. Thank you for your kind attention. Bye.